In the given figure, O is the center of the circle. So we have here O, center of the circle. AB is a tangent to the circle at point P. APQ is 58 degrees. So we'll mark that. APQ is 58 degrees. So this is 58 degrees. Let's write it out. So we have angle APQ equal to 58 degrees. Find the measure of PQB. So first, here is the radius. This is the radius. OP is the radius. And PA is a tangent, which means this radius and here tangent. So it will be 90 degrees. So angle OPA equal to 90 degrees. Now if you look at OPA, it's made up of two angles, the blue angle and now this yellow angle, this yellow one here. So for OPA, I'm going to write angle APQ plus angle, the yellow one, that is this OPQ. So I will write here angle OPQ, and that's equal to 90. This angle, I repeat again, this angle is 90. Beginning here, this full angle is 90. So now we have APQ, the blue is already given as 58. So we have 58 plus angle OPQ. OPQ equal to 90. So now angle OPQ equal to 90 minus 58, and angle OPQ will be equal to 32. Now in the next part, we already have shown that our OPQ, this angle is 32. We calculated it here, 32. And here, if you see triangle OPQ, we know OP equal to OQ, radii, OP equal to OQ, and that would be radii. Therefore, these two angles are equal. Angle, the green angles, OPQ will be equal to angle OQP or PQO. So this is 32 we have calculated. So this angle will be also 32. So angle OPQ will also be 32. So in this, the perimeter, find the perimeter PQR. So here is external point. This is our external point, and we know tangents from an external point are equal. So I have, this is 6, this also will be 6. So I will write here 6 centimeters. Now here we have another external point, and that is P. Now in this case, if this is 4 centimeters, this also will be 4 centimeters. This is equal. And we have a last external point here R, and in this case, if this is 5 centimeters, tangents drawn from an external point are equal. This also will be 5 centimeters. See, this is equal here, this is equal to this. These tangents from an external point are equal. So when we take up triangle PQR, in PQR, it is equal, the perimeter is equal to PQ plus QR plus PR, and it's very obvious. See how's the perimeter. You will start with PQ, so it will be 4 plus 6 plus 6 plus 5 plus 5 plus 4. You'll all add up all this. You'll go right along here. 4 plus 6, then you'll go 6 plus 5, and then you'll go 5 plus 4, and the total comes up to 30 centimeters. from a point P which is at a distance 13 from the center. So we take a point P here, and this is the center here, O. This point P is at a distance 13 from the center, so we put 13 here. Of radius 5 centimeters. The pair of tangents PQ and PR are drawn. So I draw two tangents now. One is PQ and PR. So PQ and PR. To the circle are drawn. Find the area of PQOR. So I join this entire area I need to find. The radius here is given as 5. Now I know this angle is 90. I know this angle is 90, radius tangent 90, radius tangent 90. So I'll first take up this triangle. I will take up this triangle here. Now in this triangle, have you seen, we know this angle is 90. So I can use my Pythagoras theorem. So here the hypotenuse, so I take up triangle POR, PQO, and here we have angle PQO equal to 90. And this will be the hypotenuse, opposite the 90 degrees. So I have 13 square equal to 5 square, I don't know PQ, plus x square. So you have 169 equal to 25 plus x square. 169 minus 25 equal to x square, and you'll get your x as 12. So I'll put my x, now I know here, is equal to 12. Now if I know that, I can find the area of this yellow triangle. The area of this yellow triangle will be half base into height. So triangle PQO is half base into height. Now what is a base? This will be my base, 12 will be my base, and this will be my height. OQ will be my height. So this is my base and this is my height. So that is into, because between the base and height there is a 90 degrees. So 12 into 5. So that would be now 30. So the area of this triangle is 30. Similarly, the area of this triangle below will also be 30. The same manner we can find out this area. So this also is 30. So the area of the quadrilateral PQOR equal to 30 plus 30, and that is equal to 60 centimeters. In the given figure, a triangle PQR is drawn to circumscribe a circle of radius 6. So we have the triangle here circumscribing a circle. So here we have the triangle surrounding a circle, and this is the circle. Triangle circumscribing a circle of radius 6. So this radius is now 6. Such that the segments QT and TR, into which QR is divided by the point of contact T, are 12 and 9, which means now this I will take as 12 centimeters and this is 9 centimeters. If the area of the triangle PQR is 189, area is given 189, find the length of PQ. So again, tangents from an external point. Here's tangent from an external point. So we have, if this is 9, this also will be 9, so I'll put that down. Similarly here for this Q, if this is 12, this also will be 12, tangents from an external point. And the last here, if this is P, I have, if this is now P, tangents from an external point are equal, so these two are equal. And in this case I will take here x and x. So my sides of the triangle are, we have PQ, the sides of the triangle, PQ is x plus 12, then we have PR, which is x plus 9, and we have QR, which is 12 plus 9. In the next part of the sum, we will divide this triangle into 3 parts. We'll here join up here like this, here and here, and we will get 3 triangles. The 3 triangles that we get is, one is triangle OQT. I'm going to mark it in green here, OQT, this triangle. Here, this triangle. Then we'll have another triangle out here, this one. And we'll add up all these areas. And then we have a third triangle here. And we'll add up these 3 areas. So we have OQT, then we have triangle ORP, and we have triangle OPQ. So we again go to the same figure, we'll draw it again. So we have this triangle. So for this triangle, we have triangle OQR, half base into height. Half, this is the base, QR is the base, and your height is OT. Now for this triangle, for the next triangle now here, OP, this one, that is triangle OPR. We have half base into height. Now in this case, this is the base, PR is the base, and this is the height. The R is the height. So we write that out. Half base, that is PR. Height is here QOS. This is S here. This is S, this is K, and this is T. And then the last triangle is this one, OQP. This also will do half base into height. This is its height. So that is triangle OPQ. Half the base is PQ and the height is OK. Now we add up all these triangles, we will get the area. So area of PQR equal to half QR into OT, one triangle. So we'll add up. The full triangle is made up of 3 parts. That is OQR, the green one, and then we have the blue one, and then we have the yellow one. So we've added up all this. So triangle POQR will put in the values, half the base for the green one. So we have now the base for the green one is 21. The height we know is 6, which is a radius, plus half here. We have the base in this case is x plus 9 into 6, plus the other one is the base is x plus 12 into 6. Now the triangle, area of the triangle is already given to us as 189. So we put 189, we take half into 6 common out. What remains here, see, I take this common out, half 6, half 6, half 6 common out. And what remains now is 21 plus x plus 9 plus x plus 12. So 189, we'll cancel this out, becomes 3, and you keep working this. So here you get 33 plus 2x, and after you work this out, you will get your x equal to 22.5 centimeters. This is a sum similar to the sum in the NCERT. In the given triangle, if ABC is circumscribing a circle, then find the length of BC. Same thing, external point B. So we have this equal to this, which means if this is 3, this also is 3. Now another external point, A, another external point. Therefore, this angle, this tangents from an external point are equal. So if this is 4, this also will become 4. But however, this entire line from here to here this entire line is given as 11. And if this is 4, this remaining part would be, this part now would be 11 minus 4. 11 minus 4, and that's equal to 7. So this blue part that we have is 7. It is 7. And tangents from an external point are equal. So this is the external point, and these two tangents are equal. This is equal to here. So this also becomes 7. Now if you look up at, if you now look out at BC, BC is 7 plus 3, which is equal to 10 centimeters. So the answer is 10 centimeters. So I'll just repeat this again. So first we started off saying that these two are equal. Which ones? This is equal to this. So 3, 3. Then we had this 4 equal to this 4, tangents from an external point, but this was 4. This entire was given as 11. If this was entire 11, that means this blue now should be 11 minus 4. Let me write that part. So AC I know is 11, and AC is made up of 4 plus, we have not marked this, say this is P, 4 plus PC equal to 11. So your PC will be 11 minus 4, your PC will be 7. So this is 7 now. We got this as 7. Again, tangents from an external point are equal, so we have CP equal to here, so 7, 7. So when you want to add up this whole thing will be 7 plus 3, that is 10. ABC is a triangle right angled at B such that BC is 6, so I'll mark here BC here is 6, and AB is 8. So we have AB here is 8. This is given as 8. And we need to find the value of x. So first we have here a Pythagoras right angle triangle. This is our right angle triangle. So in this right angle triangle, this is the right angle triangle. Let us use Pythagoras theorem. So we know this is 90 here. This will be the hypotenuse. AC will be now the hypotenuse. So we use Pythagoras theorem here. So in triangle ABC, we can write AC square equal to AB square plus BC square. So we have AC square equal to 8 square plus 6 square. So AC square will be 100, and you get your AC as 10. So step number 1 is AC is 10. So the first step we found is 10. The second step we do is to find the area of that same triangle. Now in this triangle, it's a right angle triangle here at 90. So this is your base here. This becomes base, and this becomes height. So the area of the triangle is half base into height. So we do that up. So for triangle ABC, our base is BC, which is 6 centimeters, and the height is BA, which is 8 centimeters. So the area of ABC is half base into height, and the area is 6 into 8. It will be 24 centimeters square. So second part of the sum. Now just like that earlier sum, we will divide this triangle into 3 parts. So we have this one part here, which we'll call this like this part. Then we have the other part here, which is this here, this green one. And then we have the third one, which is this one. So the whole area will divide into these 3 parts and add up, just like the earlier sum. So let's take up the first triangle, that is triangle the yellow triangle OBC, and we'll do, that is half base into height. Now the base in this case is this, BC is the base, and this is the height, X is the height. So that will be half the base, that is BC, that is 6, and the height is X. Now we'll take up the next triangle, and that is AOC. That again half base into height. Now in this case, this is the base, the AC is the base, which we already have calculated 10 centimeter earlier, and this is the height. So let's write that, equal to half, base is 10, height is X. And now we go for the last one, that is triangle AOB, and that too is half base into height, which means the base is here, in this case the base is AB, which is 8, and this is the height. So we'll write that up. So half base is 8 and height is X. So the entire triangle ABC, is made up of 3 parts. One is this, and then it is the green thing, and then we add the blue. So let's now work that out. So we have which is equal to half, we see the, here we see the yellow one is here, half into 6 into X, plus the green one is here, half into 10 into X, and the blue one is here, half into 8 into X. And the area we already found earlier is 24. So 24 equal to 3x. When you cut this out, this becomes 5x, and this becomes 4x. So 24 equal to 12x. So x equal to 24 by 12. Your x equal to 2 centimeter. So radius is 2 centimeter.